Ahoy! I'd like to talk with you about derivatives of exponential functions. We learned in the very first section of this blob of content, section 3.2, that dx of e to the x is equal to e to the x. And that's pretty useful, but it doesn't answer the question of dx of b to the x equals, or dx of e to the f of x equals. So we didn't answer those questions with this. All we have is in terms of the basic function e to the x. If it's anything more complicated, then that expression doesn't answer that question. We only get to answer that question through the chain rule. Now, I want to tell you that the derivative of b to the x for arbitrary base is natural log of b times b to the x. That's true. That meshes with this one right here because natural log of e is 1. So in the case that the base b is just the special number e, this prefactor here is just the number 1. Okay. In the case that I have a more complicated function upstairs, e to the f of x, then I get e to the f of x times f prime of x. And that's true for like basically all of the rules that we've been learning, that when there's a more complicated thing inside than just x, then you have to chain out the derivative of the inside thing. Okay, so we keep giving you the simple formulas and then leaving it to the reader to generalize them in terms of having a more complicated thing inside. And it's because if we were to do the more complicated thing, there'd be f's everywhere, and it'd always be like this trailing f prime of x, which just gets to be a lot. So let's quick do a couple of problems related to computing derivatives that involve these kinds of functions. Perhaps I should have left the rules up, but I expect you probably have also transcribed them and have them on a cheat sheet at this point. If you don't, then maybe you could click the go back 15 seconds and put them on your cheat sheet. Go ahead and start that cheat sheet now, that note sheet that you're going to be allowed to use for the midterm and then for the final, because I know there are a lot of derivative rules, and it's just a lot. And with time, you'll come to memorize them. I don't require that you would memorize them yet, but I do expect you to know how to use them if you have a list. Okay. So let's take the function e to the x squared plus 5. And I want to take d dx of that. Okay. I recognize this is an exponential function and that I've got e to the something. The derivative of e to the is e to the. But I'm not done because this wasn't just plain x up there. It was more complicated. And so I need to chain out the derivative of the part on the inside. The derivative of x squared plus 5 is 2x. And then we usually like to write these things in front so that we don't accidentally put them inside of x when we evaluate. So we'd probably write that as 2x e to the x squared plus 5. Dig it? Let's do another one. And I want you to keep doing these until they're just second nature. The more you do, the easier it's going to get. The more you're really going to get the pattern, and the less you're really going to have to depend on looking up formulas for derivatives, and the less you're going to forget to chain out the derivative of the inside function. Let's take and work on the derivative of x times 2 to the sine of x. there's f. I've got a product. The biggest thing at the top level in f is a product. So when I write down f prime, I need to do the derivative of the first. 1 times 2 to the sine x plus x times, now I need the derivative of 2 to the sine x. And I'm going to leave that as a placeholder like that so that you see that that's the step that I'm going to do when I write down this next thing. So 2 to the sine x plus x times the derivative of b to the x prime equals natural log of b to the x. So I get this natural log of b popping out when I take the derivative of b to the x. Okay? So natural log of 2 times 2 to the sine of x. And I'm not done because it wasn't 2 to the x, it's 2 to the sine of x. And so now we need to take and chain out the derivative of the sine of x times cosine of x. So kind of once you start pulling on that chain of functions for that composition of functions, you just have to keep pulling it until now I'm going to take the derivative of the inside of that thing, which was just x, but the derivative of x is just 1, and we don't bother writing it because it's just multiplying by 1. Thinking about this function, how do I want to rewrite it so it doesn't suck as much? I could try to I could pull out like a 2 to the sine of x if I wanted. I kind of want to get this like cosine of x out front, and then like, I don't know. Let's just like reorder some stuff, okay? So let's write this as 2 to the sine of x plus, how about let's go natural log of 2 times cosine of x times 2 to the sine of x. Using parens to indicate that I'm doing multiplication here as well. Okay. So keep practicing, keep doing those derivative problems. Remember to chain out the derivative of the inside thing. And you are on your way to derivative mastery. Thank you so much, and I will talk to you later.